So guys, welcome back. Again we come up with the new topic, that is the vertical circular motion. In this part we're going to see that how we can tackle the problem when the bob or when a body is moving in a vertical plane or when it is moving along a circular path. So guys, this topic is very important for exam point of view. Now let's have a look for this topic. So guys, now vertical circular motion. So in vertical circular motion, as in the figure depicted, suppose a bob of mass m connected to a light string of length r, this is r actually, r is given a speed u at its bottom. This is shown in the figure, and it is given a speed u at its bottom, and this is point A. So when a string gets turned by an angle theta, when it reaches to an position, at this position, when it will going to reach at this position, so the bob lifts by height h. So actually we have to find out that what will be this h. So if we consider that this is the reference line, A as the reference line, so we have to check it out that how much it has reached in the vertical direction, or how much height it has attained in the vertical direction. This we can see it from the figure, this figure, that this is the radius. So if we say this is actually this thing is shown that this is h. So this h will be r minus, this h will comes out to be r minus r cos theta, and this is equals to h is equals to r1 minus cos theta. So also if we look at the figure, now in this figure again, after reaching to the final position, the tension, if we'll make the free body diagram, tension will be along this and mg will be along in the vertical downward direction. So if we'll take the components of the mg, this will be mg cos theta, and along the tangent it will be mg sin theta. So this will be the free body diagram. This is the figure shown something like this. So as the body is moving in a vertically circular motion, so therefore there must be some force which will be towards the center, which will going to provide required amount of centripetal force. Therefore what we can write this as, this will be T minus mg cos theta. This T minus mg cos theta will going to provide the required centripetal force. So therefore what we can write, T minus mg cos theta is equals to mv square by r. So, hence we can write T is equals to mg cos theta plus mv square by r. Now let's take this as the equation number 1. Now by work energy theorem, what do we have? That the work net is equals to change in kinetic energy. Now as we can see from the figure, there are only two forces which are acting, that is the tension force and the mg force. So what we can write, this work done net is equals to work done by the gravity plus work done by the tension. So this is equals to, this will comes out to be change in the kinetic energy. Now where work done by the tension will be 0, how? If we look at this figure, this is something like this. Tension is acting in this direction and it is at its final position and making an angle theta. This is depicted in the figure. So the displacement of the body will be along this, along tangent to the circle. So this tension force will always going to make an angle 90 degree with the displacement. Therefore work done by the tension will always comes out to be 0. So this is what we were talking about. So work done by the tension will be 0 and work done by the gravity will be equals to minus mgh. Why minus? Because mg will going to act in the downward direction and displacement will be along or in the vertically upward direction, where h we found it out as r1 minus cos theta. This is what we found. So it'll be, so after substituting the value of h, we'll get this thing, that minus mgr1 minus cos theta. Now substitute the value, minus mgh will be equals to change in kinetic energy from work energy theorem. So we will get this as half mv square minus u square. So finally what we're going to get, v square will comes out to be this much, this u square minus 2gr 1 minus cos theta. So from equation 1 and 2, like after substituting the value of V in this equation, this. So what we're going to get? We're going to get this as T will be equals to mg cos theta plus m by r v u square minus 2gr 1 minus cos theta. So therefore, we say that the tension will be maximum when theta is equals to 0. That means at lowermost point. That means if this was the figure, if this is the figure, let's say, so tension will be maximum when the string will be over here at position A, at the lowermost point. So after substituting the value theta equal to 0, what we are going to get? Tension maximum at A will be mg plus mu square divided by r. Also, when the string will be over here, after reaching to point, let's say this is point B, this is the point B. This is the point B we have considered. So this point B, after reaching the bob at this point, the string will going to become slack. So at this point, this will going to make an angle 180 degree with the vertical. So at that point, the tension will be minimum. After substituting theta equals to 180 degree, we are going to get tension minimum at TB will be mu square divided by r minus 5 mg. This is what we will going to get. So therefore, what we can say, if we will subtract T maximum, if we will take the difference between the maximum and the minimum tension, T maximum minus T minimum, we will going to get as 6 mg. That means it is independent of the initial speed, provided the particle is able to complete the circular path. So this was all about the vertical circular motion. Guys, we don't have to remember these formulas. How we have to do? We have to only, so what we have done in this, we only have made the free body diagram, and the concept of free body diagram we used with the work energy theorem. So we don't have to remember these formula. We have to make the free body diagram and then solve the question. Now let's look at the question. An object of mass m is tied to a string of length L, and a variable horizontal force is applied on it, which starts from 0 magnitude and gradually increases until the string makes an angle theta with the vertical. Like the situation as we have discussed. Like this is the circle, and this is the string. This bob or the mass m is tied to a string. This has length L. Now it is acted upon by the force, that is the horizontal force, and this force will be variable. So it depends upon the angle theta. So what will be the so what it will be, the work done by the variable force F is after making an angle theta. So what we have to find it out. So we can say that the work done is equals to change in the minus change in the potential energy. So potential energy will be, since there will be two forces, that is again the tension force and the gravitation force. But tension the force we are talking, that the tension force, we don't have to worry. The work done by the tension will be 0. This force will going to do work against the gravity. So therefore what will be the potential energy? The change in the potential energy will be equals to mg L 1 minus cos theta. This we have done. So in this case, H will comes out to be L minus L cos theta. So therefore L 1 minus cos theta, and I have substituted this in the place of mgh. So this is what I will get. So it will be mgl 1 minus cos theta. So this is the work done by this external force. So it will be minus of minus delta u. So it will be delta u. So what we are going to get? This option C will be correct for this. Now let's look at the example number 2. A uniform rod of length L and mass m is hinged at one end is hanging vertically, the other end is now raised until it makes an angle 60 degree with the vertical. How much work is required? Now if we talk about the situation, that's something like this, that this is the center. Now rod was over here. Now rod makes an angle 60 degree with the vertical. This is the final position of the rod. Now what we have to find out, how much work is required. Again the same thing, how much work is required. Work required will be again mg, since mg h, so h will be r minus or L minus L cos theta, so it will be mg L minus L cos theta mgl. Now 1 minus cos theta. Okay, since theta is 60 degree given to us, and one more thing to note down, we are talking about the uniform rod of length L. Now this is not a point mass, this instead it is a rod having length L or a continuous body. So for this, what we have to do, so work done will be equals to mg L effective 1 minus cos theta, where L effective will be L by 2. That is the distance where center of mass will going to, or where the center of mass, or the distance between the center of mass and the center of the circle. So that will be L by 2, so it will be mg L by 2 1 minus cos 60, so it will be 1 by 2. So this will comes out to be mg L divided by 4. So therefore option D should be correct. So guys, in this part we have learnt about the vertical circular motion, and moreover we have seen various problems or how to tackle these problems when they are moving in a vertical plane along a circular path.